Hi, friends. Today on 1 Minute Math, we're looking at log laws or rules of logarithms, and we've got our basic definition of a logarithm written down there by way of review for you. The base b log of a equals c is exactly the same thing as saying b to the c equals a. We have three properties of logs, or what I would call log laws, and they go like this: the log of x times y, and I'm using just a generic log here, but whatever you could have. You could have a base 3 log, and then they're all going to be base 3. But the log of x times y is the log of x times the log of y. The log of x divided by y is the log of x minus the log of y. And then the log of x to the p is p times the log of x. How I use those would be to expand and condense log expressions and to solve equations. We're going to see one example of each of those here. Let's actually look here at number 2. If you've asked me to expand this logarithm using the log laws, the first thing I'm going to do is deal with this divided by, which means I can subtract. This is the log of x squared minus the natural log in this case, natural log of 4x plus 1, root 4x plus 1. Now I'm going to do my exponent law, log 3. So this becomes 2 log x minus, you might remember that the square root is to the 1/2 power minus 1/2 log 4x plus 1, and I'm done. I can no longer break up anything that's inside these log expressions with multiplication, division, or exponents, so I'm done. That's as expanded as it gets. Condensing is exactly the other way. If I'm given an expression, let's take this first one, and I'm asked to condense it, the first thing I'm going to do is log law 3. In this case, that turns into the base 3 log of x to the 4th minus the base 3 log of x plus 6 to the 1/3. I'm going to make that look different in the next step. And then this minus means I'm going to divide the arguments of the logs. So this all condenses to be the base 3 log of x to the 4th divided by, and now I'm going to call that 1/3 power, the cubed root of x plus 6. The very last thing we could do would be to solve equations using log laws. Whenever we see this plus here between two logs, notice that I have the log written twice. I can multiply the things together that are on the inside. This turns into the common log of x times 3x equals the common log of 12. If I have the log of one thing equals the log of another, I am allowed to cancel them. Basically, what I'm doing is taking the 10 to both sides, and that will cancel out the logs. X times 3x would be 3x squared equals 12, and now I can actually come up with some solutions. I'll divide by 3, and I get x squared equals 4, and that means x could equal +2 or -2. But here's the fun thing that happens with logs. When we go back and plug these in, I need to check and make sure, right? We always have to check and make sure that our answers make sense. If I try and take the log of -2 here and the log of -6 to see if that equals the log of 12, I'm going to freak out. I'm not allowed to take the logs of negative numbers. That one is not a solution. But we can notice that if I plug in +2, the log of 2 plus the log of 6, you can check that on the calculator. It is indeed the common log of 12. And that's it for this one. If you want a full-length explanation of this topic, please check out the video that's linked in the comments. Thanks for watching.